everybody. Welcome to Cassandra Lunch 36. That's nearly 3/4 of a year, almost there. The topic for today is going to be different databases that run on top of Cassandra, which is already a database. And there we go. The reason I picked this topic today was that in doing research for a client in which they're using Cassandra for time series data, I realized that we haven't done a presentation on this, which is what other systems rely on Cassandra that are really widely used. So this is actually not the exhaustive list. There's actually more, but for search engine reasons, we're going to put these up there because when people search for it, they'll hopefully find this video or this deck. And these are actually different types of databases. Some are time series, some are graph databases, some are a different type of time series. Akwi, this is going to be your last, I think, Cassandra Lunch before you go back to school. So I'm looking forward for when you get back. But really appreciate you doing this for not only Data Engineers Lunch, but also for Cassandra Lunch. So we appreciate that. We do need now, definitely need a co-organizer to help produce these things. We're part of Data Community DC, which is a meetup of meetups. It's a bunch of different meetups that get together and talk about data. What do we cover here? Stuff that relates to Cassandra protocol, which now is not just Cassandra and DataStax. It looks like somebody may present on ScalarDB, which is a Cassandra compliant data store. Don't believe we had any new today to say hi. Group rules, if you have a question, just ask it in the chat or you can interrupt me politely. It's fine. We at Anant are a sponsor of this meetup, and we build stuff with Cassandra and Spark and Kafka around Cassandra. We're a partner with DataStax, and DataStax is a sponsor for the group. So is GW. So are some of the other local companies in the DC and Chicago area. Thanks to also our organizational sponsors that help fund the overall Data Community DC nonprofit. And I don't think there are any announcements, but there are upcoming events always on Data Engineers Lunch, which is every Mondays at noon, every Wednesday here at noon Eastern Standard Time, and then DataStax has events. I believe there are some specific topics that are going to be coming. Well, their last one was on Spark. I think there's one topic for the next Cassandra Lunch, which will be on copy, using the copy command and different ways to hack Cassandra data in and out with copy. All right. And so let's go ahead and get into it. Lots to cover today. And as you can see, this is an exhaustive list, and this is not an exhaustive list. There's actually a few more that I didn't put here because either they're unsupported or they've just kind of fallen out of fashion. All of these, I believe, are open source. Yeah, so there's a GitHub link for every single one of them. I'm going to begin with time series because, as you can see, there's 9 of them, and you'd kind of question, why would somebody make the same thing over and over and over again on the same platform like Cassandra? And I'm curious about that too. So we can kind of look at some architectural differences, but ultimately all of these have Cassandra as a data store. Some of them, Cassandra is the sole data store. Some of them use other data stores that could replace Cassandra, or Cassandra can replace it. Some of them have other systems like Elasticsearch to help query that information. And remember, this works on all Apache Cassandra. It doesn't need to have specialized data stacks with Solar indexes or Alessandra with the Lucene Elasticsearch index. In the time series databases, I would say there are 2 general categories. One is databases that are for scaling something like Prometheus or CarbonDB. And these databases were created, Prometheus or CarbonDB were created specifically for like systems information in time series, like to like power something like Opcenter, for example, or Grafana. And Prometheus, does not have a high availability system. It tends to crash. So what people have done, they've come up with several different types of Prometheus compliant databases, just like there's several Cassandra databases. They come up with several Prometheus compliant databases, which basically can store Prometheus data historically. There's one technology called Cortex, which it's fairly popular, and what it does is it provides long-term storage to Prometheus. So even though users can still use Prometheus as like, hey, what's happened in the last hour, Cortex basically can store it for the long term. There's another database I'm not going to cover here because it doesn't use Cassandra. It's called Thanos, and Thanos is similar to Cortex in the sense that it fans out the query to other databases that are other Prometheus databases, and it caches that information. And then people use Prometheus and Thanos together to have like a super scalable time series data for metrics information, systems metrics information. You can obviously use Prometheus for other type of data that isn't like metrics, meaning like how fast is the Cassandra database, or how much data does the Cassandra database have right now? And then it stores that every moment, right, going forward. But that's not the only reason that people use time series databases. So that's one category. So I would, in that I would just say just monitoring / metrics, right? So it's like Prometheus / Carbon compliant. And the interesting thing about these is that they tend to, because they're using the Prometheus protocol, they can be combined, they can be connected to a system like Grafana to visualize that information. So what does Prometheus API look like? They have a thing called PromQL. And essentially imagine having every single thing that changed in your system for multiple servers, all inside one database. And you can say, give me the HTTP request total for this particular job in the last 5 minutes. And it gets you the time series information, right? And so when you combine Prometheus with Grafana, you get a visual, line chart, right? So, so Prometheus, Grafana, they're all kind of part of the same project, right? Then you get stuff like this, okay? You have seen Grafana in Astra's like monitoring view. More than likely, they're using some sort of Prometheus on top of Cassandra, or they're using some other Prometheus, scaled Prometheus. Prometheus as a service, okay? So Cortex database architecture, if we take a quick look at it, so Prometheus still exists, right? It's still going to be there. But generally what happens is, that bottle of water was not open. Prometheus sends data to the distributor. Distributor has an ingester. Ingester puts it into Cassandra, and then there's a query service that then reads and provides this data, right? So that's what Cassandra is doing for Cortex, right? This is Cassandra being stored here. And they have other versions that use other data stores, but Cassandra is going to be the most, it's going to be the fastest one, right? Because it's a database, right? filodb, this project started off as initially just like a Spark SQL database in memory, running on top of Cassandra. And then over time, it became a Prometheus compliant data store. But it's, and it's also built on top of Spark and Akka and Kafka on top of Cassandra. So it has everything except, Mesos or whatever. So this is the person who made this basically made this initially to be an example of the SMAC stack, right? And that's what it was supposed to be. And then over time, it became, it's funny. This is no longer Stargate. But basically, filodb became, a place to store data and query data from Cassandra. Okay. And it basically follows the Lambda architecture. So basically to achieve this real-time data store. It's an interesting place to see how it works, but in terms of code, you can get data into the system using Kafka and just send data to Kafka. And then Cassandra stores the data, and then they use Spark SQL. Now, this alone isn't going to be fast enough for some people, right? So that's why they added a whole layer inside filodb, which makes it easy to query. I'm trying to find a picture here. Here we go. I don't think this is it still. Yeah, I was going to show a diagram of it. I think he has taken it down. But filodb, the guy who made it, that company TupleJump is now bought by Apple. So, and he still maintains this project. So if I were to deduce from that information that maybe Apple uses it, and because I know Apple uses Cassandra, maybe they use filodb for their Prometheus data store, right? There's another one called Cyanide. Cyanide is an older database and looks like nobody's really committing to it, but it's an example of somebody using CarbonDB protocol, which is a different protocol for storing information. And that was the Graphite. And Graphite was the precursor to Prometheus. So people have been trying to do this for a while now, right? It's not just recently. It's just a thing that, when you're trying to do time series information, you need an API. And that's what these things do. They provide an API. But storing time series information is not the actual challenge. The actual challenge is being able to query that information. And in time series databases, they call that chunking. So these systems overall have a system to ingest data, aggregate data for certain granularity, and then to store that chunk somewhere. So when you ask for the 5-minute average or the 15-minute average or the 30-day average, it's able to just pull it from Cassandra rather than having to calculate it. Okay, and that's a common thing that you'll see in the architectures of all of these databases is essentially ingestion, some sort of like chunking, and then a query system. I'm going to put in here custom time series, but people probably use it for metrics. There's no reason you can't. It's just that there won't be a pretty Grafana interface that out of the box just works with it. One notable one is Heroic from Spotify. And Heroic DB, I think also uses Elasticsearch for the indexing. So the chunks are also stored in Elasticsearch for quick query. Where did it go? Yeah, there we go. So, it doesn't have to, but basically it can use Cassandra to store it, or you can use Bigtable. It can use Elasticsearch for the metadata, but you don't need to use it. And then it can use Kafka for the consumer, but you don't need to use it, right? So it's got a few different modules. What is a time series database? What we just talked about. People can use it for storing metrics for a particular server or a distributed system. We talked about, before, why we need to collect logs from different places. So you wouldn't necessarily put log information there, but let's say you extracted from that log some latency or if the system itself has an exporter, a Prometheus exporter, it can export that data directly here. But what about your own application, having certain numbers or values? you don't have to just store a number, you can store a value. All right, so user sessions. This user came and visited the site here. They did this here. They did this here. And then that information could be used to basically suggest topics or sites or target ads to make them think that some people are monitoring them at all times, because that's what people do with advertising data. And so a generic time series database can be used for a lot of different things. This is more of a specialized time series database. The other databases are very similar, and to different degrees are either still being used. So let's say Kairos DB had a commit on November 19th. I think people probably still use it. I know Spotify still uses HeroicDB. OpenNMS has an internal database for scaled. OpenNMS is open network management software, and they call their system Newts. And so their last commit was basically 2 days ago. And to store their data to visualize what's happening with the network. So why didn't I put this in this category? Because it's not a common protocol. It's just it's a protocol that's only applicable to OpenNMS. I'm going to just verify to see if it does support something like Graphite. I don't think it does, but it's just good to check. Nope, it does not. That's okay. But it provides a JSON interface to write data and to read data and to do queries on it. And it's basically it's a good way to understand how to make scalable software. They basically made this software to scale out there. I think Postgres database was their normal database, and it wouldn't handle tons and tons of information. So then they had to do something like this on Cassandra. Hawkular is a Red Hat owned project. And Hawkular basically does metrics, alerting, inventory type stuff. Although I think they use it for a variety of tools, basically not just metrics information, but also tracing information, right? Like tracing means if you have a distributed application, right, what's happening, you store all of that, and then you can visualize it, right? This thing did this, then this thing did this, then this thing did this. So tracing is just a different type of time series use case. But metrics DB is metrics for time series database is basically what all of these are right here. These are slightly older, but I wanted to give them kind of like an honorable mention because they were the pioneers. So Racker Labs, basically where Cassandra came out of, they made something called Blue Flood, and Blue Flood is one of the earlier, time series databases running on top of Cassandra, and hence it's easier to understand. It's not. I don't even think it uses CQL. It might be using the old Thrift protocol. But the reason I tell people to take a look at this stuff is there is some good, nugget in every piece of source code that has had some traction. It's always something. Even if people come and replace it with other technology, and they generally take the best thing out of the old technology and they put it into the new one, there's always something you can gain from looking at the history of the technology. So in this case, what I learned was in their architecture was they also support Carbon, all right, and allow you to do Carbon queries, and Graphite Web was the way to look at Carbon queries. And let's say I wanted to do that, I could take a look at how they did that, right? Because Graphite is I don't know if it's people who still use it. There's probably some people still use it, but there's some value in seeing like how did they make their API, right? In Java, for example. And then finally, Open Time Series Database is the granddaddy of a lot of these. You'll see that it's referred to by many of them. Then what they say like, oh well, I was inspired by Open TSDB, for example. and it continues to get commits as late as last year, October. And OpenTSB runs on top of Cassandra, although it can also run on top of HBase. It has, been used, I think, by really, really large companies because it was one of the first ones. But yeah, this is the general kind of like survey of time series databases. Any questions before we go to another set of databases?
What is a carbon something you mentioned, right?
Yeah, so Carbon, like Prometheus, okay, is a protocol for storing time series database, right? And you can send data to it and then retrieve it. I'm thinking, is this it? Let me see. Carbon. Of course, the chemistry stuff is coming up. Time series database. This is graphite. Graphite basically was used to store metrics, store data into graph it visually, and internally it had something called Carbon DB. Okay, that's what it was. It's just a way to store data, right?
Okay.
And so now people generally use Prometheus. Okay.
Okay.
Got it?
Yeah.
That's it. That's all it is.
So Prometheus is made up of the nuggets that were in graphite? Or
yeah, they got the best out of it. And Prometheus is basically like the Prometheus and Grafana. So graphite and carbon were the old one, right? Prometheus and Grafana are basically the current way of doing that, right? And I think it even says somewhere it's like the successor for graphite or something. It's not on this page, but I'll take a look. Yeah, so like everybody, right? Everybody uses it. And no wonder there's 4. I just showed you 2 Prometheus compliant databases that run on top of Cassandra, right? There's like 5. There's 5 different systems that scale out Prometheus, written in different ways. Right, so that's what Prometheus is. Any other questions before we go forward? Okay. All right, so now we get to the graph databases. Of course, I shouldn't discount graph, DSE graph. And actually, I'm going to put it in here. Excuse me. So the first kind of like, top database that was graph database that ran on top of Cassandra was called TitanDB. Okay, and TitanDB, the company that was sponsoring that project got bought out by DataStax, and so essentially that became DSE graph. Right, so TitanDB's old source is still available, and so TitanDB runs on Apache Cassandra. It can also run on Hadoop HBase. It can run with Solar. It can run with Elasticsearch. So, let me see if I can find a TitanDB. And when DataStax bought it, the group rather, over time they stopped making commits to it, and that basically became Janus Graph. There's some like history behind, they were trying to basically call it Apache Olympian, but DataStax was like, no, you can't just take this and, it continued to extend it. And so Apache was like, well, we don't want to go against what DataStax is saying. I'm kind of paraphrasing this, but ultimately, Janus Graph became part of the Linux Foundation, but they share, right? So Janus Graph and DSE Graph and Huge Graph even, they all kind of have a lineage from TitanDB. And TitanDB stores data on the graph, of the graph, right? The nodes, edges, and relationships. But it uses, it's called Tinkerpop, which is a framework for running graph traversals. And it uses a language called Gremlin. Now, the group that works on Tinkerpop worked on Titan. They work for DataStax still. But the people that pioneered Gremlin, which is kind of like the lingua franca of the common language, right, basically of graph databases, is now used with a lot of different databases, right? So that's kind of like a side story about graph databases. But the code for Titan is there. This is the TitanDB architecture. As you can see, it can store data in Cassandra. It can and then it can index these the data in these other systems. And it provides both an OLAP and an OLTP. OLAP meaning, you know, online analytical processing, parallel processing via Spark, Giraffe, or Hadoop, as well as OLTP to do, you know, real-time in and out of data. Oops. So where does Janus Graph come in? Well, Janus Graph is now supported and backed by companies like IBM, a couple other companies as well. Let me see if I can bring it up. Here we go. Nope, they don't have it. But let's see where the architecture is. Oh yeah, no, I have a link for that. There we go. Slide 14. So Janus Graph is obviously similar to architecture in TitanDB. It's just, it picks up where TitanDB stopped. And what I think has added in the last 5 years or so, or 6 years now, is people are doing this stuff on Kubernetes, people are scaling it out. And so there's generally use cases that other people still do. There's a talk at, I think it was one of IBM's conferences. Yeah, that's when they stopped. Here we go. Where like they use Janus Graph at like huge scale, right? So it's, because Janus Graph is free, people can use it for billions of vertices. Architecture, there you go. So, you know, doesn't look that much different from TitanDB. In fact, it's basically the same, right? It is exactly the same. But recently, I found that there's yet another database that follows in the footsteps of Janus Graph. TitanDB. It's called Huge Graph. Huge Graph can work with several different databases, including Postgres, RocksDB, ScalaDB, Cassandra. ScalaDB and Cassandra are very similar. HBase. So you'll note that it, you know, says it gets its general storage structure from Titan, right? It's not a fork of Janus. I don't think it is. I think it uses the same concept, but I don't think it's actually a fork. If anything, I think that they are using different technology. No, they're still using Java. I was thinking maybe they use Scala. But I have not tried it out. I'm curious to see how it scales. Just one thing to note, that folks in China made it, and most of their documentation is in Chinese. It took me a while to find out their architecture. Oh, yeah, another cool thing is that they have their own kind of like UI, which I don't think Janus Graph has. You have to use something else. Architecture. No, I had a link here. I'll show. Oh, there it is. Architecture. So what do they do? So they use Cassandra/Scala. They use Cassandra/Elasticsearch for the index. And then they have schema on Cassandra as well. And they tend to kind of separate what can be done with OLAP versus OLTP. Their architecture seems similar, except that they also have the studio, right? They have a UI that users can use to look at that information. All right. So that wraps up and for completeness, I am going to put DSC graph here. I don't want to, even though it's not open source, I feel I would be cheating DataStax if I didn't mention DataStax graph, because the group that made TitanDB continues to operate DataStax graph. The main difference is that you have to pay for DataStax graph, and or because it's part of DataStax. And the other thing is that it has changed. Now you can put data in Cassandra using CQL and retrieve using Gremlin or vice versa, which is not possible with all of these. You can see the data, but it's like a storage format inside Cassandra. There's a question. Yep, thanks for coming, Eric. You'll notice that if you use DSC graph and compare it to Janus Graph, it's kind of like comparing apples and apples, because DSC has Solar, it has Spark, it has Cassandra. At least for the Solar part and the Cassandra part, up until the latest version, you would see similar, performance. But lately, in the newer versions of DataStax, it's a different ballgame. It's like way faster. And that brings me to the final set of databases that run on top of Cassandra. And they're, I don't want to say niche, but they're more like APIs to store and retrieve information. And you'll see what I mean. First, I want to just give a shout out to Stargate. So Stargate is a wrapper on top of Cassandra. And interesting thing about Stargate is that the Stargate nodes are actually part of the Cassandra cluster. There's a flag in Cassandra where you can say, bring up a node, but don't store any data, right? And if you're part of the Cassandra cluster, you're automatically a coordinator. So you can have like 20 nodes in your Cassandra cluster in a cluster of 100 that are, quote, Stargate nodes, right? That don't have any data. All they do is they serve requests. So it's like a built-in load balancer. That's all part of Cassandra, by the way, right? But then on top of that, on the same Stargate nodes, they have REST API. They have Cassandra. You can do Cassandra on those nodes. You can do CQL on it. You can do JSON queries with CQL on it. And then they added REST and GraphQL services on top of it. The goal is that you can use different databases. So you can use Cassandra, you can use DataStax, but ultimately, what does it feel like? You can dump documents and retrieve documents very similar to Mongo, right? Or you can make schemas in CQL and retrieve it via REST API. And so technically, the things that you see on Astra, DataStax's Cassandra as a service, their REST API and their GraphQL API, that's what this stuff is, right? So Stargate, really cool. Up until Stargate, I would have, if somebody were to ask, hey, what would you recommend to quickly get an API up and running? I would say, look at something called UserGrid. I don't know if UserGrid is still being maintained, but there's a project called Apache UserGrid. And let's see when the last GitHub commit was. I've already forked it. Okay, that's right, because I was looking at it. I didn't want to fork it. I just want to go to see it. So last commit was December. So somebody's still maintaining it. And Apache UserGrid is basically like the free version of Apigee, which is an API gateway. And you could like quickly make a backend as a service. It's really powerful. It runs on Elasticsearch and Cassandra. So the fact that people are still maintaining it, I'm going to put this back. I'm going to put this back on our list here. All right. And the Apache UserGrid architecture is interesting to note because it can use an internal queue, basically with ACA. It has a built-in internal queue, and they don't really have it. And here we go. Or it can use, I think, SQS. But ultimately, they also have code to embed this, backend as a service inside an Android app, an iOS app, or a JavaScript app. And there are companies that use Apache User Grid to run their backend as a service. So if you go to baas.io, hopefully it's still around. Some of these companies, they come and go. Apparently now they do blockchain too. But yeah, Apache User Grid, it's definitely still usable. And then finally, Scalar DL and Scalar DB. These are two projects from a company called Scalar. They've given talks on this, but Scalar DL is a tamper-evident scalable distributed ledger. It's not blockchain, but it's a ledger, meaning that everything is kind of like, because it's in a distributed system, everything is ACID compliant for the ledger to be accurate. And because it runs on Cassandra, it can be highly scalable. So what does the ledger do? You give it data and it basically says, I got it. And it's in a sequence of data that cannot be changed. If you break or delete or modify data, then essentially the ledger is no longer credible, right? So if you use the API, obviously. The other thing that they have is called Scalar DB, and they use Scalar DB to power Scalar DL. What is Scalar DL? Oops, wrong one. Sorry, we just talked about Scalar DL. What is Scalar DB? Scalar DB is just a raw data store system. You can have some schemas in there. And I've read their paper. I've read I've looked at their decks. Ultimately, the way it does it is it always uses lightweight transactions, and it essentially says, here's my random hash that I make. Make sure that it goes in there. So it just uses lightweight transaction every single time. And that's the reason it's ACID compliant. So it's a library, right? It's not a service. It's just a library that you put in your code, and all of a sudden your application is ACID compliant. Let's see. So, technically what it's doing is using Cassandra, right, to do a transactional system, not reinventing it like these other people, right? So it's just a way to leverage what you already have. And you add it to your code, right? And you do all your data mutations via the Scalar DB, and it makes sure that it gets there, right? And if you want to look up something, it's going to make sure that nobody's writing to it when you're looking it up, things like that, right? So very cool technology. And if I were to give one more database to take a look at that is powered by Cassandra, it's called Restbase. Restbase isn't a database. Restbase is the distributed storage engine for the Wikimedia Foundation. If you're not familiar with the Wikimedia Foundation, it's the company that runs Wikipedia and all of the different wiki websites. And it essentially is a table storage backend that conforms to a table storage API similar to DynamoDB or Google Data Store, right? So what is the implementation that they have for their data storage? Cassandra, right? That's what they use for their storage. So when you go to when you go to Wikipedia, right? Whenever you're looking at a page, you're not seeing that data coming from MySQL, because that's what Wikipedia software is built on. MediaWiki, the software they use, is built on PHP, right? That's not what you're getting. What you're actually getting is a cache of information, right, that has been stored inside Restbase that was rendered by PHP. And that's what you're seeing. So the scale of Wikipedia, if you can imagine, how many different pieces of information are there that are rendered on a daily basis. And let's say somebody makes an edit, right? They make an edit that then has to be seen by a million people potentially. The reason they use Cassandra as a backend is because you can edit once and it gets cached in Cassandra, and then Cassandra can scale. It can send that data to as many people as it needs to, right? If I can quickly show you the diagram, which is kind of what I'm trying to do with every single one of these. There we go. There we go. Is the Well, I can at least show you the spec. The spec is what is implemented. So you basically make a table like this, and you give it, hey, these are my attributes. I want some indexes here, right? I want some secondary indexes here. And it implements it in Cassandra. And you can do queries like this. And you're not really writing CQL. So it's useful to take a look at. People are, obviously going to continue using this because Wikipedia is not going anywhere. But honestly, if I were to kind of toss it up between UserGrid or Stargate or Restbase, I would put my money on Stargate. And maybe I would take a look at UserGrid, because UserGrid has a portal. You can have orgs, you can have teams, you can have users. Users can have their own data store. When your app needs a backend as a service to have like its own user authentication system, their user preferences, this out of the box has all those, right? So that's the only reason I would say take a look at this. It's still being maintained apparently. And then Stargate, if you want to build on top of a solid architecture, this is what I would recommend. And then maybe look at Restbase to learn how to make a very, very scalable cache. All right. So we covered how many? More than 3 here. So 1, 2, 3, 4, 5. We covered 18. Wow, 18 different databases. Awesome. I think so. Any questions?
Yeah. So when you use these systems, are you connecting to your own existing Cassandra clusters? Are you bringing one up for use specifically with these systems, or are they handling that?
Good question. For the most part, you have to have an existing Cassandra cluster for the most part, unless you use the Stargate like startup, or the UserGrid has a kind of a startup, minimum viable, get it up and running. Then you're generally doing that. There may be on some of these like a Dockerized version of it for like development, but when you go to production, you're probably doing your own. But you don't have to these days. There's like Astra, Instacluster, these services, could be another way to basically connect to it and then use these things on top of that. Does that answer your question?
Yeah.
Cool. Any other questions? So anybody think that they would go out and kind of check out these different databases anytime soon? Maybe it's interesting for some project they're working on.
Yeah, Rahul, this is Sunny. Yeah, sure. This is very interesting to know about these new databases. But just a question regarding the licenses for these databases which are on top of it. So how does it go about, like in terms of license and costing and everything?
Sure. So except for DataStax Graph, all of them are open source. So I would assume there's no licensing cost, but there would be licensing restrictions if you pay attention to the license as to what you can do with it. Most of them are loose, meaning you can make a derivative product and have it internally and not have to distribute it back up. but I'm not a open source lawyer. But it's, it's worth, if you plan on distributing the software in some way, I would make sure to take a look at the details, especially these days with like Elasticsearch, for example. They have a very restrictive license. Amazon basically has Elasticsearch as a service. They released a different Elasticsearch fork, basically. But yeah, free. I would say most of us, except for Janus Graph, these are all free.
Thanks.
Yeah. Yeah, and with Docker and with Kubernetes, I mean, once you get it configured, right? These are all pretty much stateless systems. So management of these things are much easier today with containers than ever before. And Stargate is a really good place to take a look at how they figured that out, right? So look at their Kubernetes charts and look at their Docker containers and how they, have it all connected together. Because before you would have to have your own Terraform to create it. Then you'd have to like pull down the code and configure it with Ansible. Then you'd have to have potentially, load balancers in front of this stuff. Now you could just have your Cassandra database, whether on Kubernetes or not, but like primarily people still just do it on virtual machines. And then you can have a Kubernetes cluster or use, Amazon ECS, something like Fargate, where you say, hey, make this container scale, or go to Cloud Run on Google, make this container scale, and it takes care of the load balancing and everything for you, right? So considering the modern tools today, I would encourage people to take a look at these databases first, especially the last ones I showed you, right? Like how to use an API that's already built. But then the Timeseries databases. More than likely, you have an application that needs to track metrics or analytics. Worth a try. May not fit the need, but it's at least worth a try. Right. Anything else, guys? All right. Well, awesome. Thanks everybody for coming. We'll give you back 5 minutes of the day, and I'll see you guys next week, same time, same place. I believe Arpan is going. JB, did you have a question?
No questions.
Oh, okay. Arpan, I believe you're going to be giving a presentation on using just the out-of-the-box copy command in Cassandra for like data in and out, JSON stuff, right?
Yeah, so right now I'm planning on just like doing a couple of data operations that we could do with CQL copy. So like we're gonna export likely gonna use a Dockerized Apache Cassandra container and then mount it with a couple files. So that way we can just do everything within the container. But essentially export data as CSV and then import data as CSV. And then also within that data, we can do JSON, kind of show you what the possibilities are.
Cool. Very cool. Awesome. Looking forward to that. Yeah, that's, I found the name for it. It's called Open Distro for Elasticsearch. That's the fork. But anyways, good to see you all. Have a wonderful rest of the week, and I'll see you next week. Thanks.
Thank you.